So, good morning, ladies and gentlemen. Thank you all for being here today. My name's Chong. I'm representing South Survey to show you something new on the market about GNSS industry. Well, it's about SLAM RTK. Yeah, as the topic says, GNSS positioning while satellites unlock. Now, possible. Let's go. It's all because of me. All because of me. Let's show you a video about our latest product, SLAM RTK. Okay, I would like to draw your attention to the 4 parts here. So we made it happen, and we brought a new concept to the industry. Then, few test results and best fit applications. Finally, review and summary. Okay, first, we made it happen. We all know that GNSS business is booming nowadays, right? As you may find plenty of exhibitors promoting GNSS and selling receivers like takeaway boxes, right? Cheap, low, right? Why? It's more user-friendly. It's more cost-friendly, of course, than ever before, which makes it much more popular. As a matter of fact. And another important reason is that GNSS is the core technology in our geospatial industry, right? It's closely related to so many equipments, solutions, and products. Yeah. Then we all know that satellite signals are a must to obtain differential corrections and then fixed solutions. When we stay in the wide open air without any obstructions or say few, it's quite fairly easy to obtain the result. On the contrary, when we go to the complex environments, let's say semi-open air, and then with certain obstructions, that's not. It's hard. And then, see here, in reality, we do encounter some challenging cases, right? We say it GNSS unfriendly or GNSS-denied environments. So if we want to measure those points in the shelter or obstructed areas, it's difficult with regular RTK, with conventional RTK receivers, right? Maybe we use total station and then switch to a go straight total station. It's not that efficiency, right? Or we use total station first, switch to, RTK first, and then switch to total station. Not efficient at all. Nowadays, we come up with a new solution to challenge this kind of environment. We say it magic calculation. It's a reverse computed result based on SLAM trajectory reverse computation. You may see it. That day, we measure a point in the stairwell at the rooftop, which is just a few steps away, assessing outdoors. And in the picture, you may see it's in RTK working mode, and SLAM working status is on. But that time, there were only 12 satellites log and 15 satellites track. So it's hard to get a quality fixed solution, right? Nowadays, all the multi-constellation receivers can track and log 40, 50, or even 60 satellites at a time. Here, it shows that it's not in the ideal conditions. So what we can do is to obtain the mixed solution that deploy GNSS and SLAM, right? Okay. Let's show you in another way. So at top, in the GNSS-friendly environment, easy. Differential corrections, easy. Fixed or flow solutions, right? How about in the unfriendly and denied areas? In the past, no way, right? No way to get fixed, no quality result at all. How about now? We are introducing magic calculation. So we come up with mixed solution, GNSS plus SLAM mix and match combo. So new solution. We are bringing up a brand new concept to the industry from the Chinese society. So how does it work and how it came along? So everybody knows that SLAM helps mobile laser scanning from outdoor to indoor. In the past, we rely on GNSS for mobile laser scanning, maybe airborne, maybe automotive, right? We need GNSS for positioning, for locating, right? And then in recent years, SLAM changed somehow, right? Even indoors, we can do laser scanning, right? We can have our positions, have our coordinates, right? It works because of SLAM, right? This is the most important reason that we come up with a new solution. And then check how it works. Our product is a perfect mixture of GNSS and SLAM. So at top, it could be used as a regular RTK rover, okay? So single cam RTK rover for AR stakeout. And then at the bottom, it's gonna be used as a RTK-based SLAM handheld. And then in the middle, you see the SLAM working status is on. So we can expect GNSS plus SLAM merge applications, mix and match combo. 1, 2, 3, magic cal, AMS, and super stakeout. Well, easy to understand. Outdoor, open air, no obstructions, fixed, right? How about switching to indoor, switching to shelter, obstructed areas? For all the other conventional RTK receivers, I'm sorry, sayonara, goodbye my love, right? But with our new products, with the latest inventions, we can do mixed solution to work it out. We call it mixed solutions. And here, I don't think it's necessary to explain a lot about the definition of fixed solution. Everybody knows it well, right? Then we come up with a brand new concept to the industry, mixed solution, right? It's a reverse computed result scientifically derived from the time synchronization of SLAM trajectory and the earlier GNSS positional records. GNSS plus SLAM makes a match combo. So from the right, you may see from fixed to mixed, we change one letter only, a single letter difference only, right? Fixed is easy to understand. Mixed also. Technically speaking, I would like to say maybe somewhere else somebody call it fixed, F-I-X fixed. I don't buy it because from any encyclopedia or textbook, it was delivered to us as F-I-X-E-D, fixed, right? So it should be fixed, not F-I-X. That was a very typical Chinglish mistake in grammar. As a responsible and leading GNSS manufacturer, we are introducing the correct ones. Mixed solution, from fixed to mixed. That is our philosophy. So they are related in meaning and similar in spelling. That's the magic from South Survey. Here you may see a surveyor intends to measure a concrete column corner point that time, right? It's semi-indoor, semi-outdoor, right? You can see the sunlight outside, but already sheltered and obstructed. How he worked? From fixed to mixed, he did it. He did it, right? Maybe some of you might be curious and cannot wait to ask, how about the accuracy performance of mixed solutions, right? What's the accuracy level that mixed solution, Magic Cal, can achieve? Okay, let's come to some test results. So outside a building, it's same. That is a car park over ground, first floor. Inward, we just measure some points. Total station as the checkpoints. And then Magic Cal with our SLAM RDK as a reference to compare, right? It makes sense to use an old methodology to compare with the new equipment, right? We always do this, right, in the surveying society. So from here, you may see the deviation is quite small, just a few centimeters or even millimeters, because it's quite close at the first moment. That is 0.1, right? The first location to compare. And then we go forward, go inside. You may see still a few centimeters difference only. For the testing, we are always serious because we have to be responsible for our products. Same. But here, point number 4, 17 centimeters. Something wrong there. I was not in the case. I was not in the story. And then I checked with our engineer, what did that happen? How it came? He told me that that time, before he make it stable, right? He got the result already. So that one is incomparable, not good to compare. So you see already indoor, inward. Normally, within a distance of 50, 70 meters, we can control down to 5 to 10 centimeters. I think it's quite efficient compared to total station survey, right? We don't need repeated station movements, right? We will not suffer with, from the intervisibility troubles, right? Okay, it's another field test that I did in Thailand early this year, right? So we obtained 2 coordinates through course and trip RTK, and then put prism backside, and then total station at the ideal position can be visible to indoor, can be visible to another car park basement overground. So we measure 10 points with total stations, coordinates. We measure 10 points with our SLAM RTK, the new product. So like this deviation, only 2 points got problems. What happened? First one, actually, we measure under the shelter, a shelter, right? Before the, in front of the residence. That time, we got, we checked and logged more than 45 satellites, I think, and then we got fixed. But in my opinion, that's a fake fix. Don't trust it, right? The conditions was bad, shelter already. How could be that many satellites, right? So that one, no good to compare. And then point 6, what happened? That time, we did not impose the tilt survey function into our new product. That's why in elevation, it goes bad, it went bad, right? And then another test in Malaysia, middle of this year. Same, car park overground, right? No other choice for conventional RTK, but SLAM RTK can do. Same, total station measurement, and then SLAM RTK measurement, compare. See, deviation, all below 10 centimeter. That time we walk much further inside. So some of you might be curious about its best fit applications. Well, see, first one, utilities survey. Or we say pipeline survey or pipe network digitization, right? Flyover, bridge, no way, right? With the new one, we can do it. So if we work with total station, bad intervisibility, right? We cannot change the reality, right? And also, yes, we can go in the evening, but that's not the working hours. Yeah? On the right, same, pipeline survey, utilities survey for the residential areas. Also difficult to obtain fixed solution close to the tall buildings. No way, difficult. But with SLAM RTK, we use magic cal to challenge while satellites are locked, as the topic says. On the other hand, we use air mass, like airdrop, iPhone airdrop, right? I name it air mass, air measurement, right? Air measurement to do contactless measurement, because we have the laser, right? And then still, we can do SLAM scanning to reconstruct 3D reality. With one equipment, we can accomplish plenty of results. Sounds good? So these are other similar scenarios that we need SLAM RTK to challenge. Close to the building, and then under the shelter, obstructed areas, we manage the survey that it was not possible before. In the past, you have to set up a total station in the visible location and then take a prism pole by another guy, right? Now, easy. So for this rollout engineering layout, under the bridge, fly over, satellite unlock. Now we do it. We do it. Here's another typical example. Indoor coordinate acquisition. So with the SLAM RDK, actually performing the SLAM function as well, right? We put it into the backpack with the tri-black, right? Customized. Recording coordinates and video streams at the same time. So these raw data would be used for indoor mapping purposes perfectly. Instead of SLAM only, we were collecting coordinates. This is quite important. So let's show you a bigger picture that on our mind. So in case one, easy. Everybody does it, right? Friendly environment, fixed solutions. Case two, connected to satellite, commercial satellite systems instead of radio-based or coarse stations. So we do PPP, precise point positioning. And then let's go further, look further. In case three, rover working indoors fails to track satellite signals but turns to SLAM. Then we can expect mixed solutions, right? GNSS plus SLAM, mixed solutions, okay? So Rome was not built in a day. This is the history of South Survey. We came up for years, for decades, to have so many models for the industry. And in recent years, SLAM RDK is our GNSS RDK hybrid supreme signatures to the industry, okay? And then in brief, in short, just keep in mind, magic calc helps a lot, right? And it helps us in the GNSS unfriendly and denied areas, environments, okay? And then it can achieve 5 to 10 centimeters accuracy level, right? It's good for some particular applications such as utilities survey, roadway engineering layout, etc. And then here's another video to show you one of its distinguished features, photorealistic colorized point cloud effect. As it sets as a slogan, map it real for this product. Map it real. See it, please. From true color point cloud to reality is just one product away. It's me. Not me, it's me. Okay, thank you. Thanks again for your time. And I hope that you came to understand more about the new technologies from South Survey. I think it will be a great tribute to the industry. So, once again, my name's Jackie Chong from South Survey, China. Take me, go with me. Thank you.